Okay, in this question, we have a blurred image form because the image is formed here and the screen is here. So the screen does not really capture the image. So what can we do to focus the image on the screen? That means we have to make sure that the light ray converges or intersect each other at the screen. Okay, let's look at the 4 options. Okay, by moving the object away from the lens and the screen, okay, the further you move this object backwards, the image will be formed nearer to the lens. So this will not help the image to be focused on the screen. So this is wrong. Okay, move the screen further away. If you move the screen further away, it does not catch the image that is formed here. So this is also wrong. Using a brighter object at the same position will only yield a brighter image. So this is wrong as well. Okay, using a lens of a longer focal length at the same position, that means the light ray, it will converge at a later time, something like this. So this will help the light ray to intersect at the position of the screen. So D is the correct answer. What is the property of all EM waves? Let's go through all the options. Okay, they are deflected by magnet. This is wrong. Okay, they are positively charged. It's wrong also. They are neutral. They travel at the speed of sound. This is wrong because they travel at the speed of light in vacuum. And they can travel through a vacuum. This is correct. Okay, they do not need a medium to travel. So answer is D. Okay, in this question we are asked which component of the EM waves does the scanner use to detect the development of the baby? Okay, straight away we can eliminate gamma ray and X-ray because they are highly energetic and they are going to harm the fetus. Okay, and for infrared waves we can eliminate as well because infrared waves cannot pass through the skin to reach the fetus. So the only answer left will be ultrasound. Ultrasound wave is sent into the womb of the woman and it will reflect off the fetus, and there's a receiver here that will catch the reflected signal and it can form the image of the fetus here. Alright, we have a pressure distance graph of a sound wave. So we can see that the pressure actually increases from atmospheric pressure to a point that is higher than the atmospheric pressure, and then it goes down to a point that is lower than the atmospheric pressure. So we can say that this highest pressure, it should be the compression, center of compression, and the point with the lowest pressure, it should be the center of rarefaction. Okay, so rarefaction is indicated by Q, and the wavelength, it will be the distance from the compression to the next compression. So it will be indicated by distance X. So the answer should be C. Okay, in this question we have a positively charged sphere X and a negatively charged sphere Y with a very small positive charge P placed in between. Let's look at the interaction between X and P. They are both positively charged, so P is going to be repelled away, so it's going to move in this direction. Now let's look at the interaction between P and Y. P is positively charged, Y is negatively charged. Since they are unlike charges, they will attract each other. So it will also cause P to move in this direction. So movement of P, it will be towards Y. And the force between X and Y, because they are unlike charges, they attract. So it should be attraction. So the answer should be B.